Hello class, this is a video tutorial on bivariate data. In this video, we'll be looking at the line of best fit. From a scatter plot, an estimated line can be drawn to predict values from the presented data. While there are more accurate methods for drawing lines of best fit, this method is more accurate than just purely guessing. And here are the steps that we do it in. We draw an oval that surrounds all the data, and then we halve the oval to find the line of best fit. There should be equal numbers of data points or dots above and below the drawn line. So let's just do a quick example here. So first, always do this in pencil, by the way. First, we draw an oval as equally as we can. As equally as you can. That surrounds the data like this. Then we find the halfway line of this what's it called, of this oval. We kind of cut through like so. Now, just to quickly double check, I mean, you can stop at this point, but to quickly double check, just count how many dots are above the line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many are below? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is not a good line of best fit. I'm just going to quickly adjust mine here. Thankfully, I've got a digital screen that lets me do this. There we go. I've included 2 more. 11, 12. This line of best fit is more suited. Let's try this one more time. Let's draw an oval around data and just kind of estimate a line that cuts this oval in half, like so. Again, counting how many dots are above and below the line. So above, 1, 2, 3, 4, 5, 6, 7, 8. Below the line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so clearly there's not enough points above the line, so I'm just going to quickly move mine down like so. Once again, this isn't the most accurate way of doing it. We're going to find better ways of doing this later on, but this is better than just quickly just going, oh, it's kind of like that. Okay. Halving this oval looks kind of like this here. There we go. Okay, so let's now use the line of best fit to predict values. So from a drawn or given line of best fit, we are able to estimate data that have not been collected. There are 2 ways of doing this. It's called interpolation, or just to interpolate data. To interpolate means to estimate data within the given data range, and this is more reliable. And to extrapolate data means to estimate data beyond the given data range. Let's do an example to show what this means. Okay, so use the line of best fit to estimate the given values. In this one, there is no line of best fit, so let's draw one. Drawing a little oval. Let's try and get data points above and below the line. So how many do we have now? We have 1, 2, 3, 4, 5 above, 1, 2, 3, 4, 5 below. So this is a proper line of best fit. So now, using this line of best fit, we can estimate the values of, so let's estimate the value of y given x is equal to 15. So when it says given x is equal to 15, we go to 15 on the x values. Then we go up. Actually, let's do this in purple. Oops. Let's do this in purple so we can see. So x equals 15. So we go to 15. We go up to where it touches the line. And then we go across to see what value that is. That's about 15.5. Okay, so that's the answer I'm going to use. So when x equals 15, according to this line of best fit, y is it's approximately 15.5. So let's estimate the value of x given y is equal to 12. So y equals 12. Here it is, going across. Hits this point here. That's about 13, so it's a bit less than 13. So I'd say x is about, what's past halfway? Let's say it's just about 12.8. This first example is called interpolation because the values that we estimated was within the data range of the x and within the data range of y. So let's extrapolate the value of y if x equals 18. Notice how this line of best fit should really stop about here. But 18 is all the way up here. So this is now what's known as extrapolating. We're taking data beyond, beyond the range that we've been given. But we can still guess what it is. So 18, let's go all the way up. Now, to really guess this, we're gonna have to extend our line. So it's gonna look kind of like that. Yeah? And that point there is gonna hit this point all the way up here. That's 18, 19, 20. So from this, we're gonna guess that y is approximately 20. So let's extrapolate the value of x if y is equal to 10. Well, y is equal to 10 is all the way down here. That's y equals 10. So we're going to go across. Notice again how this is below the points that we've been given. So let's just guess by extending our line. It goes about to this point here. So it's under 12. So I'd say it's about 11 points. That's 11.2 or something like that. So x is approximately 11.2. Okay, let's do one more example here. Use the line of best fit to estimate the given values. Estimate the value of y given x equals 30. So given x is equal to 30, we're going to go x equals 30. Going to go up to this point here. And let's find what the y value is at that point. It's about, from the looks of it, it's about here. Okay, so that point there looks about, that's 20, that's 30, so this must be 25 here. So halfway between 25 and 30, I'd say that's about y is approximately 27.5. Let's do this again. Let's guess or estimate what x is given y is equal to 12. So we're given y is equal to, 22. So 22, that's 25. 22, that's 22.5. 22 is about here. So that point there, we go across. I'm trying, actually no, what am I doing? It's about here. I'm gonna go all the way across. And where it meets is this point here. That spot looks about 42 from the looks of it. So x is approximately 42. Once again, that is interpolation because the values that we guessed was within the range of the line of best fit. So let's extrapolate the value of y if x is equal to 55. So x equaling 55 is all the way here. All the way here in case you didn't see it. So if we were to extend this line all the way up, notice how the line of best fit does not hit that range. So we're going to have to extend that line and guess where it will be. From the looks of it, it's going to hit this point here, which corresponds to that point there. That is y is equal to 15. Extrapolate the value of x if y equals 40. So y equaling 40 is all the way up here. Once again, notice how it doesn't hit the line of best fit. So we're going to have to take line of best fit and extend it. Would be about there from the looks of it. And that point where it would hit looks like it'll be x equaling 5. X is about 5. So I hope that gave you an insight into interpolation and extrapolation, as well as using the line of best fit. Hope to see you in the next video. Best of luck.